current setup may have several issues. Firstly, bonding the generator neutral to the frame at the generator creates a parallel path for fault current between the utility system and the generator system, which can be hazardous and may damage equipment. Secondly, the generator neutral should be isolated from the system ground to prevent circulating currents and maintain the integrity of the grounding system. Thirdly, the conduit from the generator to the emergency breaker should include a grounding conductor to provide a low impedance path for fault current and maintain the grounding system's effectiveness. To correct the situation, the following steps should be taken. 1. Connect the generator frame to the system grounding electrode conductor using a suitable bonding jumper. This will ensure that the generator is properly grounded and potential differences are minimized between the two systems. 2. Disconnect the bond between the generator neutral and the frame. The generator neutral should remain isolated. 3. Install a grounding conductor number 12 American wire gauge or larger in the conduit between the generator and the emergency breaker. This will provide a proper grounding path for fault current. 4. The ground ring of 4 ground rods can be abandoned since the generator frame is now bonded to the system ground. The isolation of the generator neutral at the generator should be maintained through all wiring connections. The grounding conductor in the generator conduit should be a continuous length without any splices. All electrical connections should be made in accordance with applicable codes and standards. Properly grounding a generator is crucial for safety and reliable operation. Here's a detailed explanation of why the original setup poses risks and how to implement the recommended solutions. Let's start with the core issue of neutral ground bonding at the generator. In a properly designed electrical system, the neutral and ground are bonded only at one point, typically at the main service entrance. This single point bond ensures that fault currents have a clear and safe path back to the source, allowing protective devices like circuit breakers to trip and clear the fault. When the generator neutral is bonded to the frame, it creates a parallel path for fault current. This means that fault current can now flow through both the intended grounding conductor and the generator frame itself. This parallel path has several negative consequences. Firstly, the ground fault current may divide unevenly between the two paths, with some current flowing through the generator frame. This can cause the frame to become energized, creating a shock hazard. Secondly, the impedance of the generator frame path may be higher than the impedance of the grounding conductor. This higher impedance can limit the amount of fault current that flows, potentially preventing the circuit breaker from tripping quickly enough to prevent damage or injury. Thirdly, the parallel path can also create circulating currents in the grounding system. These circulating currents can interfere with the operation of sensitive electronic equipment and can even cause overheating of conductors. Therefore, it's essential to isolate the generator neutral from the frame to avoid these problems. Now, let's discuss the importance of isolating the generator neutral. As mentioned earlier, the neutral and ground should only be bonded at one point in the system. When the generator is running and supplying power, it becomes a source of power, and therefore, the neutral should not be bonded to ground at the generator. Instead, the neutral should remain isolated, and the grounding should be provided through a separate grounding conductor that connects the generator frame to the system grounding electrode. This arrangement ensures that fault currents have a clear and direct path back to the source, allowing protective devices to operate correctly. It also prevents circulating currents and maintains the integrity of the grounding system. Moving on to the absence of a grounding conductor in the generator conduit, this is another critical issue that needs to be addressed. The grounding conductor provides a low impedance path for fault current to flow back to the source. Without a grounding conductor, the fault current may have to find its way back through other paths, such as the conduit itself or other metallic structures. These paths may not be designed to carry fault current, and they may have higher impedance, which can limit the amount of fault current that flows. This can delay the tripping of the circuit breaker and increase the risk of damage or injury. Therefore, it's essential to install a grounding conductor in the conduit between the generator and the emergency breaker. The grounding conductor should be sized according to applicable codes and standards, and it should be properly connected to the generator frame and the emergency breaker enclosure. Now let's discuss the recommended solutions in detail. First step is to bond the generator frame to the system grounding electrode conductor GEC. This is typically done by connecting a bonding jumper from the generator frame to the nearest accessible point on the GEC. The bonding jumper should be sized according to applicable codes and standards, and it should be installed in a manner that provides a reliable and low impedance connection. This connection ensures that the generator frame is at the same electrical potential as the system ground, minimizing potential differences and reducing the risk of electric shock. The second step is to remove the neutral ground bond at the generator. This involves disconnecting any connections between the generator neutral and the generator frame. The generator neutral should remain isolated and insulated from ground. This ensures that the generator neutral is not inadvertently grounded, which could create a parallel path for fault current. The third step is to install a grounding conductor in the conduit between the generator and the emergency breaker. This involves pulling a grounding conductor, number 12 American wire gauge or larger, through the conduit and connecting it to the generator frame and the emergency breaker enclosure. The grounding conductor should be sized according to applicable codes and standards, and it should be installed in a manner that provides a reliable and low impedance connection. This grounding conductor provides a clear and direct path for fault current to flow back to the source, ensuring that protective devices operate correctly. The fourth step is to abandon the ground ring of 4 ground rods. Since the generator frame is now bonded to the system ground through the GEC, the ground ring is no longer necessary and can be abandoned. The ground ring was likely installed to provide a local ground for the generator, but this is not necessary when the generator is properly bonded to the system ground. Abandoning the ground ring simplifies the grounding system and eliminates any potential for circulating currents. In addition to these steps, there are a few additional considerations to keep in mind. Firstly, the isolation of the generator neutral at the generator should be maintained through all wiring connections. This means that the neutral should not be connected to ground at any point between the generator and the emergency breaker. Secondly, the grounding conductor in the generator conduit should be a continuous length without any splices. This ensures that the grounding conductor provides a reliable and low impedance path for fault current. Thirdly, all electrical connections should be made in accordance with applicable codes and standards, such as the National Electrical Code NEC. This ensures that the electrical system is installed and maintained in a safe and reliable manner. Some specific considerations related to the generator block heater circuit are worth mentioning. The block heater is typically a small 120 volts heating element that is used to keep the generator engine warm in cold weather. The circuit for the block heater should be wired with a hot, neutral, and grounding conductor. The grounding conductor should be connected to the generator frame and to the grounding terminal in the block heater enclosure. The neutral conductor should be isolated from ground at the generator as discussed earlier. In the situation described, the fact that the number 12 American wire gauge ground wire for the block heater circuit is bonded to the ground screw in a 4-inch square box in the generator is not inherently problematic, as long as the generator frame is properly bonded to the system grounding electrode conductor GEC. The issue arises if the generator neutral is also bonded to the generator frame, which creates the parallel path for fault current that we discussed earlier. To summarize, the key to properly grounding a generator is to ensure that the generator frame is bonded to the system grounding electrode conductor GEC, that the generator neutral is isolated from ground, and that a grounding conductor is installed in the conduit between the generator and the emergency breaker. By following these steps, you can ensure that the generator is grounded safely and reliably, protecting people and equipment from electrical hazards. It's also important to consult with a qualified electrician or engineer to ensure that the grounding system is designed and installed in accordance with applicable codes and standards. The National Electrical Code, specifically Article 250, provides detailed requirements for grounding and bonding electrical systems, including generators. Familiarizing yourself with these requirements is essential for ensuring a safe and compliant installation. For example, NEC Section 250.30 covers grounding requirements for separately derived systems, which includes generators. This section specifies the conditions under which a separately derived system must be grounded, as well as the methods for grounding it. NEC Section 250.32 covers grounding requirements for buildings or structures supplied by a feeder or branch circuit. This section specifies the conditions under which a building or structure must have a grounding electrode system, as well as the methods for grounding it. NEC Section 250.34 covers generator grounding and bonding. This section addresses the specific requirements for grounding portable and vehicle-mounted generators. NEC Section 250.166 covers sizing the generator grounding electrode conductor. This section provides guidance on how to properly size the conductor that connects the generator frame to the grounding electrode system. Proper grounding and bonding is not just about safety, it's also essential for ensuring the reliable operation of electrical equipment. A properly grounded system helps to minimize electrical noise and interference, which can improve the performance of sensitive electronic devices. It also helps to protect equipment from voltage surges and other electrical disturbances. In addition to following the requirements of the National Electrical Code, it's also important to follow the manufacturer's recommendations for grounding and bonding. A generator manufacturer may have specific instructions or requirements that are not covered in the NEC. Following these recommendations can help to ensure that the generator is grounded properly and that it operates reliably. When working with electrical systems, it's always important to take precautions to protect yourself from electrical hazards. This includes wearing appropriate personal protective equipment (PPE), such as insulated gloves and safety glasses. It also includes following safe work practices, such as de-energizing circuits before working on them and using lockout/tagout procedures to prevent accidental energization. Electrical work can be dangerous, and it's important to be properly trained and qualified before attempting any electrical work. If you're not comfortable working with electrical systems, it's best to hire a qualified electrician to do the work for you. Ignoring proper grounding and bonding practices can have serious consequences, including electrical shock, fire, and equipment damage. Taking the time to properly ground and bond your electrical system is a worthwhile investment that can protect people and property from electrical hazards. Remember to always consult with a qualified electrician or engineer to ensure that your electrical system is designed and installed in accordance with applicable codes and standards. Staying informed about the latest electrical safety practices and technologies is crucial for maintaining a safe and reliable electrical system. The electrical industry is constantly evolving, and new technologies and techniques are being developed all the time. By staying up to date on the latest developments, you can ensure that your electrical system is as safe and efficient as possible. In conclusion, generator grounding and bonding is a critical aspect of electrical safety and reliability. By understanding the principles of grounding and bonding, and by following the requirements of the National Electrical Code and the manufacturer's recommendations, you can ensure that your generator is grounded safely and reliably, protecting people and equipment from electrical hazards. Remember to always consult with a qualified electrician or engineer if you have any questions or concerns about generator grounding and bonding.